Hello everyone, it's December the 8th. Alright, just watched the video telling me that the demo I watched yesterday about Gemini, the Google's new multimodal model, was heavily edited. I mean, it was still impressive and all, but definitely not at the same level as I felt yesterday. When I was watching the video yesterday, my jaw was on the floor. I was like, wow, the model can just, you show the model a picture and it can start reasoning with you. That was a whole different thing compared to what actually happened, where the model required the pictures, right, and text prompt. So Google basically edited the demo. I mean, everything really did happen, and they're not really trying to hide anything because they did publish the quote unquote secrets behind, like they show you all the prompts and everything they did to make Gemini respond in a certain way. But the demo's definitely twisting the truth, and then twisting a big way. Okay, a big way. You cannot hold a conversation with Gemini the same way as the video show. You just start making hand gestures, and Gemini will understand immediately. Oh, this is a rock paper scissors game. No, that's not how it happened. It requires hints. It requires text prompts. It probably also, not probably, it takes time for the response, and then in the demo they just cut out the latency. That was pretty bad. That was pretty bad. I mean, I don't know. Like, if you want to hype this thing, yeah, they definitely worked, but just you hype it for like 1 day, 2 days, and then people start digging into it, and then they realize, nah, that's not true. And even the benchmarks, right? The benchmarks is also, there are a lot of oily things happen in the benchmarks. Like, sometimes they don't compare apples to apples, because the models is, there are so many ways to trigger a model to give you a response, right? There are multi shots or zero shot, or like what they did with Gemini, there was a chain of thoughts. Like, all of those different ways, you cannot compare Gemini with one way of triggering to, say, ChatGPT with a different way of triggering. That's not good, right? You cannot say like a 5-shot method compared to a 0-shot method. That's not a fair comparison. And apparently they did mix those up in the demo video to show that Gemini outperforms ChatGPT on almost every aspect. Yeah, but some would say, yeah, this is just business. This is not the science talking. It's not the real scientist talking. It's probably just marketing team talking. But still, it just every day by day, it just Google starts just to feel like dropping down to the same level as all the other companies. They start doing these shady things, and like, are they really lying? No, they're not lying. They put everything out, but if you don't follow up, or if you don't actively look into it, then you will not know. You will start believing that's what Google's capacity is for Gemini, but it is not. All right, anyway, that was a little bit disappointment early. All right, we have. I guess they just start doing easy problems from now on, which is, again, I'm not complaining because I have this thing to go through. We have the idea and we're gonna implement it today. This is just in order traversal, right? And we put into a list. Yeah. Okay. This is in order. Where is my IntelliJ? I think the best way will be we put a list. Right? And we're gonna do here. If root is null, no. Here with a null, is returned. Right. Otherwise, rest.add. Ooh, that was not right. That was not right. Okay. That's we need to have a private void. In order traversal. Yeah, void what? Helper, which is tree node root again, right? And then we say if root equal to null, return. Otherwise, rest.add root.val, and then what do we do here? Helper root.left, helper root.right. Just as basic as they can get. And this we basically just call helper on the root and return res. I hope I didn't make any mistakes in this one. Wait, what? I expect 1, 3, 2. Wait, how? Oh, in order. I think I got it in order wrong. I think in order should be left first, right? Left, root, right. That's in order. What I did is pre-order. I was thinking about pre-order from yesterday. Yeah. Yeah, there's nothing special for this. It doesn't really matter too much. Uh, 94. All right, so that's not what we're trying to do. This is the one. Okay, we're gonna Python this thing. So again, we need to get yesterday's notes out. Yeah, I think I remember. All right, let's do this. Let's do this. We can do this as 4.9. Okay. I'm gonna go Python this. Okay, so what was the formula? It's k num1 minus k times num2, right? Num1 minus k times num2. So if num1 is smaller than num2, then return -1. This is not possible. Okay? Because num1 minus k times num2, k smaller is 1, so num1 minus num2 has to be positive. In fact, if it's a 0, it's also not gonna work. Right? If it's a 0, it's still not gonna work. Because we cannot make 2 to the whatever power to become a 0. So, okay, so that's that. Then we can say k equal to 1. Okay, we can say while true, because I don't really know. And the temp, right? Temp is num1 minus k times num2, right? And what we want is a binary version, so we might as well just do binary this 2 to the n, right? That's the binary version. Then we need to count. Oh, actually, I think Python has count bits, right? Count bits. Bit count. Okay, so if we have big count, we don't have to turn it into this. So this is not necessary. This is not necessary. This. Oh, I do need this. So we need this. No. We get a temp out first. Okay, so we get a temp out, and a k is equal to 1. So we do a count first, right? So we say if temp dot bit count. We can say bit count, right? Equal to temp dot bit count. If bit count is larger than k. Continue. Might as well, you need to do, hold on, if it's equal to k, then we'll just return k. We find it. Okay, we find it already. The first time that it hits, then we find it. If bit count is smaller than k, bit count is smaller than k. So now we need to check the last one, because the last one is not gonna work, right? So we can say so bit count should be minus temp and 1, right? Temp and 1. So this is the remaining. I say if, because everyone can double. So if that, right? So what I'm saying is if this, oh my god, I always got it wrong. If 2 times this, okay? If 2 times this, so I remove the last bit, okay? I remove the last, because the last bit cannot double. Everybody else can double, right? So I remove the last bit, and every other bit I can double. So now when times 2, that's the maximum. That's the maximum amount of bits I can handle. So the maximum amount. If that is larger or equal to k minus temp and 1, right? Because if the last one, if the rightmost is a 1, then k we need to minus that. So for the remaining. So if this is true, right? If this is true, then we shall return k as well, right? So we might as well put this up. If this and this also return k. So k is possible, right? Otherwise, k plus equal 1, then we keep going, we keep going. And eventually, the hope is eventually we'll get to 1, that this one will work. But it's also possible that you will go infinity. So there is an upper. Yes, there is an upper for k. I remember there's an upper k. What is the upper for k? Is when this is all 2 to the 1. So the maximum, right? What's the maximum? Maximum k. Yeah, so everybody's 2, right? And then we have k of them. 2 times k equals num1 minus k times num2. Isn't that the maximum? Well, when k gets big, I mean, if num2 is positive, we will hit negative, right? If num2 is negative, then if num2 is negative, and basically this plus this. Yeah, what is the maximum on k? It can't just keep growing, right? If k keeps growing, hold on. So one thing for sure. This shall be while num1 minus k times num2 is largely equal to 0, right? So these two are not necessary, right? So if it's larger or equal to 0, then we do this and we'll return -1 here. But what if nums2 is a negative value? If nums2 is a negative value, so this just gonna get bigger and bigger and bigger and bigger, right? So as it gets bigger, I hope there will be at a point where the bit count, actually I'm not sure about the bit count. Huh. Yeah, what is the maximum you can get for k once you get it up? The maximum on k. So yeah, let's just m2 is, let's just say this, right? And then there's gonna be this plus the next one. Right, so a plus k times b equal to 2 to the I0 plus 2 to the I1 plus da 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 plus 2 to the ik. So what could the maximum k be when k get really, really big? If k get really big, this one will get really big. So this will also get really big. Or can we prove that there gotta be 1 that would make it work? I have no clue. I'm gonna submit it. I don't have a good proof, but might as well just submit it and then just see if this makes any sense. Okay, we can have num1, num2, num1, num2, 1, 2, 3, 4, 5, 6, 7, 8. Let's see. Does that make sense? Yeah, my bad. It's num2. Seem to make sense. Not the best at using this, but I think this shall work. Okay, it doesn't work. How about this? I put another parentheses around. Okay, and I need 2 parentheses for this. 1 minus 1? 10. Okay, let's just 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the biggest you can get. If the biggest can handle, then everybody else can handle. Yeah, so I think this will be right. Okay. No. 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 It's not correct. Either we have error. Oh. I think we definitely got some. Oh, that's far from what we want. That's fine. That's fine. Let me just, So 71 and minus 13. Expected 5. Okay, let's see. Num1, num2. Make integer 0. Num1 and num2. Right, it's not right. Okay, so what we can do is print and do the binary of this. This is what I want to see. Okay, and then do that. Doesn't matter. We just do the binary. Of course, I need k as well. Okay. So 1, 2 is not gonna work. 3 is not gonna work. 4 is not gonna work. Because we way too much. 5. 5. Huh. I think my idea probably is not all correct. So k equal to 5, right? So k equal to 5, and what I got is 1, 0, 0, 0, 1, 0, 0, 0. And we have 2. I say the most I can get is 4. But this is 5, that's why it's bad. But what I think happens is we can definitely break this down. Oh, we can break this down into 1, 0, 0, 0, 0, 0, 0 plus 1, 0, 0, 0, 0, 0, 0, right? And then we have a 1, 0, 0, 0. And this can keep bringing the, oh my god. You can keep bringing it down. So for each one, holy crap. It's not just double. You can double it. Each one can keep double it. Each one can keep doubling it. Holy crap. Okay, so that means depending on how many things I have, right? So this one can become 2. This one can become 2. This can become 2. So how many total I can get all the way down to the to the bottom? So it's like if it's 1, 0, 0, I'm just do 1, 0, 0. So we can split into 1, 0 and a 1, 0, right? And this can split into 1 and 1. This can split to 1 and 1. So the total will be 7, 2 to the 3 minus 1, right? So just total the maximum bits, 1, 2, 3, 4, 5, 6, 7, 8. So this is 2 to the 8th minus 1. That's the maximum this thing alone can create. Okay? This thing alone can create. And that's a gigantic value. That's a gigantic value. And every single one can create, right? Therefore, we can compute a total number. So what will be So can we find a fast way to compute the total? Yeah, I can just go from right to left. We find one, and then we do find one and do, yeah. All right. So we have to be smaller than k. This is for sure, right? This is for sure. And then we don't do this. we ignore the last. So while this, oh, how do we say this? So we go left to right. So big count smaller than k, right? So we can say remaining is equal to k. Okay? And then while remaining is larger than 0, we need a I equal to I equal to 0, right? So we left shift, right? So we left shift and we say temp left shift equal I. Left shift 1. Yeah, it's fine. Temp left shift 1. No. Temp left shift. Okay, hold on. Temp. Yes, temp left shift. Temp and 1, right? Temp and 1. I need to count. So the current number of bits, right? Count. So I have a C equals 0, right? So we do that, and shall be if this remaining minus equal to 1 left shift C, the number of bits, minus 1. Okay? And then, if that, otherwise we don't do anything, and temp left shift equal to 1, and C plus equal 1. While remaining is larger than 0, remaining will minus, and eventually remaining will get out. Right, will definitely get out eventually. Also temp has to be larger than 0. So while this and temp, right? While this and temp, we do blah, 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 blah. When we get out, if we still have remaining, right? If we still have remaining, that means we're bad, right? So we say if remaining is still larger than 0, we'll continue. But if remaining is smaller or equal to 0, we'll return k. Right? But if it's larger than 0, then we'll keep going. Okay, so it will be like this. Ugh. I enter forever. That's very interesting. How? C equals 0. 1 left shift C. I did C. Oh, that's wrong. Right shift. There we go. Right shift. My bad. This is a right shift. I think this one should be right. Yeah, each one can produce a lot more than what you had expect. I thought it's multiplied by 2. It turns out it's not multiplied by 2. It's a lot more than that. Okay, try this one. Oh my god. Output -1. Answer should be 5. That is very interesting. Holy crap. Wow, this one is tough. Okay, let's try. 135, 26. How is my get out? I should not have. Now I have to do it again. So main temp 2 to the end. Okay. 1, 2, 3, 4, 5. How is this one? Yeah, the algorithm is wrong. Big count is smaller, that's true, right? Remaining is 5. C is 0, remaining is 5. And temp, okay? Temp is 1. C is 0, 1 left shift. Huh. I think I know where the problem is. I think this is 1. I think this C should be 1. Because this C is the count, the number of bits. So we start with this, right? So C shall start with a 1. I can't believe it. Everybody is still correct. One more time, double check. Oh, man. Mayan. Yeah, I think it's a pretty good problem. It took a lot of efforts. I think this is a good problem. Took me quite some efforts. Okay, so we can try. What we want to find is the smallest k, right? The smallest k such that num1 equals to num1 minus k times num2. Num1 minus 2 to the I0, 2 to the I1, well, 2 to the IK, right, is equal to k times num2, right? This means we want to find a way to break num1 minus k times num2 into k binary values, all in the form of 1, 0, 0, 0, 0, right? Apparently, if num1 minus k times num2 is negative, it is not possible. Otherwise, the minimum number of the minimum k, right? The minimum k for any num1 minus k times num2 is the number of bits in that value. Thus, if the number of bits is equal to k, we have found k. If the number of bits is larger than k, we have failed, right? It is not possible. Right? We have to increment k. If the number of bits is smaller than k, then we can decompose each bit into 2 more bits. This means for a pth bit, right, it can be decomposed into 2 to the p minus 1 bits. So we simply try to obtain the max number of bits, right? The max number of bits possible for each the max number of bits possible for the max of bits decomposable, right? Decomposable. And as long as that value is larger than k, we have found the answer. I have no idea. I don't know the runtime for this. But I feel like we can do better. Right? Bit count, that's fine. But here, instead of doing this, we might as well do Bing temp equal to binary temp, 2 to the n, right? And then we say for for I, right, B enumerate binary temp, we do have a count bit decompose bits, okay, right? So all we need to do is, as long as we have enough to cover, then we're good, right? So the top, what we're gonna do is decompose bits will be, well, it has to be if b is equal to 1, right? If b is equal to 1, then we can say, oh, undo. Okay, so this shall plus equal to what? This shall plus equal to 1 left shift is the number of bits of len bin temp minus I, right? If 1 0 0 0, that's 4, so the first one is 4. 3 2 1, yes. So, and then we need another parentheses here. Right, this minus 1. And then we say if decompose is larger or equal to k, then we return k. Otherwise, we just keep going. Once it's not good, oh, D8J. Okay, is it working? It's working for this. I'm thinking maybe this one will be faster. Maybe, because I'm going from the left to right. So I'm getting the bigger bits first. Yeah, it's faster. We're getting the bigger bits first. Cool. And not too shabby, doesn't it? All right, let's see what are other people's opinions. Bit count. Bit count 4 lines. Jesus. Start from 1. Check if can be sum of k power of 2. The maximum operation is num. Ah, that's true. Maximum operation is num. The minimum operation is num bits count. I got that one. I did not get this one. The maximum operation is num. Yeah, everybody is 1. Ah, yeah, 1 plus 1 plus 1 plus 1 plus 1. That's true. So if k is in between, the num can be You don't have to do 60 operations. You just, keep going. I'll still upvote, but we definitely have a solution 2 waiting for us. Might as well. Inspired by Lee 215. He pointed out that the max number of bits for the max possible k given num1 plus k times num2 is the value num1 plus k times num2 itself, right? Because it can be broken down into 1 plus 1 plus 1 plus plus 1, and total num1 plus k times num2 ones. Beautiful. So we're gonna use this. Everything else will be exactly the same, so we're gonna go here, we're gonna copy everything, but just do, oh no, that's not what we want. That's interesting. Let's see if this, no, we want to do j, right? Let's see if we can paste this. No, we cannot. So when you, oh no, we can. So even though it was not successful, we can still do this. So we undo it, but it's already in the buffer. Cool. So bit count, this is the maximum, right? So this is the minimum. This is the minimum k. Okay. And max k is temp itself, right? So if k is in between, right? If k is in between, then we'll return k. Otherwise, this k will be plus equal 1. And tanh. Otherwise, we'll return this. Alright, let's give this a shot. Try it. Yeah, right. Hold on, I might as well just call this max k, right? So I save this. Max k. Yep. No. Max K. Should run it first, just to make sure that it works. Faster. So much faster. Okay, that'll be it. Yeah, I'm gonna call it a day for today. I think the next one will be a hard one, right? Still a medium. That's fine. Alright, I'll see you guys tomorrow. Adios.